Welcome back. Today we're going to explore the crucial topic of risk assessment, which will cover the last two sections of the TAR process defined in Clause 15 of ISO CE 21434, more specifically 15.8 and 15.9. Up until now, we have an understanding of damage scenarios and impact, threat scenarios, and feasibility, but what do we do with this information? Understanding how to assess and manage risks is essential to ensuring both safety and security. Let's dive into how we determine risk values. Risk assessment starts with understanding risk determination. The risk value is calculated by considering both feasibility and impact. We use a 1 to 5 scale to measure risk levels. The combination of feasibility, how easy it is for an attacker to exploit a vulnerability, and the impact of such an event helps us assign a precise risk score. These tables are translating the attack feasibility levels and the impact severity. In the standard, we also have another approach to doing so using a numerical scale. Here we use a quantitative approach to risk calculation. The impact and feasibility are quantified using their scale impact using 0 to 3 scale and feasibility with its own breakdown of values based on the summation of each feasibility category, which allows us to categorize the severity of potential attacks. By translating qualitative assessments into a quantitative assessment using numerical values, we can more accurately align with the risk matrix and calculate a risk score, although both methods may yield the same result even without converting to this numerical scale. This helps in combining the factors into a single quantifiable measure that informs our cybersecurity strategy. So now we have our risk values. What do we do with them? Now let's talk about how we handle risks once they are identified. There are several risk treatment options available. Avoiding the risk. This involves removing the source of risk altogether. For instance, if a feature is assessed as having a high risk, we might decide not to implement it. Reducing the risk. Here we apply mitigating controls to reduce the likelihood or impact of the threat. This often includes implementing security controls recommended by industry standards like NIST. Sharing or transferring the risk. Sometimes it's more efficient to transfer the risk to a third party, like through an insurance policy. Accepting the risk. In some cases, the only option may be to accept the residual risk and continue with operations, especially if mitigating it further is not feasible. The outcome of the TAR process is a finite list of factors that contribute to stakeholder risks. This includes product assets, potential threats, vulnerabilities, and their organizational impact. By prioritizing risks associated with critical assets, we can guide the design of more secure automotive systems and shape a stronger security strategy. As I mentioned, there are many ways to reduce risks, applying security controls, modifying designs, and more. So what happens after we've applied our risk treatments? We're left with what's called residual risk. This refers to the risk that remains even after mitigation measures have been applied. It's essentially the potential harm that could still occur. The way you would calculate this residual risk would be to apply a feasibility level to a security control that acts as a threshold. So once you apply that control or mitigating factor to the threat, it will reduce the risk level to now consider the new feasibility level. Remember, impact levels may stay the same since the consequence is always there. In the case of impact, there can be room for improvement, such as thresholds provided by HARS and ASIL, ratings that help you determine the maximum impact value for a given damage scenario. Some tools can calculate a residual risk score after cybersecurity controls have been implemented. If this score still exceeds the acceptable risk threshold, we may need to consider further mitigations or other risk treatment decisions, such as risk transfer strategies. Effective risk management is about making informed decisions. By quantifying both visibility and impact, we can prioritize our security efforts where they're needed most, ensuring that we protect critical assets while aligning with industry standards like ISO SE 21434. Before we end this last section of TARA, I want to cover some general tips and common pitfalls. such as ensuring consistency in damage scenario definition, consulting specialists, asking for help, and understanding components, as well as assumptions about operational environment and vehicle architecture, security target description, asset identification, threat description, and residual risk awareness. This concludes our last requirement and section for tire-specific processes according to the ISO SE 21434 Clause 15. I hope this has been informative. The following sections are additional topics on cybersecurity goals and requirements, both of which are important when you get to the cybersecurity concept phase of your process. Be sure to check out our separate videos on exercises where we go through 2 example tires.